I hope you watched the previous video that we did at around 1 o'clock, because there we talked about a lot of interesting things, and I have explained some of the difficult things about glycolysis there as well. We're going to continue from there, and right now we will do the part two. Now, people who have been following our page so far, thank you for doing that. Thank you for all the love and affections that you are providing us with. And I would definitely request you to go check out our ODA app. You can find it in Play Store, Apple Store, all of these places. Specifically, why I'm asking you to do that is because our YouTube classes are good. We take these classes regularly on YouTube and we're trying to do it better every day. But our application allows you to take live classes. In YouTube, you cannot talk to me much. I don't get to see what you're writing, and I fail to help you directly through the platform itself. But अगर आप free classes try करो हमारे साथ through the app itself, it's great. You get to talk to the teacher, have a conversation, learn directly from them, hand-holding process, and so much more. So go check out the app. Not only that, the app actually has a lot of different types of courses. One of the best courses that we provide is our crash course. Eh, Sorry. So when it comes to our crash course, it's one of the best because within a week, which starts from Monday every week, you will be able to learn from best of the best teachers in the country, both science and maths and English as well. This is something we are giving new. And within that time period, you will also have the help of a personal teacher. For example, I'm a master teacher. I teach hundreds and hundreds of students in a classroom. So I cannot talk to everybody. Kabhi kabhi, I can't finish all your doubts as well. So for that reason, you will be provided with a personal teacher. The personal teacher will be there for your support. You can talk to them if you don't understand something. You can ask them doubts, conceptual clarity, and so much more. With that, with that, you will still also have much more content to go around. You will have ebooks to practice. You will also have homework for every class for the whole week and test on the app itself. Great, right? You don't have to go anywhere. घर पे बैठ के आराम से you can take all of these opportunities and make the best out of it. So go check out the application and also check out our course. Now, remember one thing, you can enroll for this course from the app as well as from other places, but the course fee is 499 for a whole week. Would you like to join for a cheaper price? I can actually give you a scholarship that will reduce the course fee from 499 to 29 or 99 or something based on your class. If you want to know how, make sure you watch this whole session right now and then we will proceed there. My name is Sourajit Das. People who have been following our page, you must have taken so many classes with me. I'm back again to teach you something more, and we are going to continue from the topic that we left last. I'm a molecular biologist, so I love learning about chemistry, but on a molecular level, organic chemistry as well as biochemical reactions. And these are kind of my specialty. Mera dominant area, I'm very OP in that. So I've been teaching biology for quite a long time. It's my seventh year running actually, and I have so much amount of experience in teaching online. I have taught more than 4 lakh students, and I teach every day hundreds of students here at ODA Class. Come join some of my live classes in the app. Definitely you're gonna enjoy. So today we continue from the part that we left off from. This is the part two of biochemical processes in which we are discussing about glycolysis. As we discussed in the part one, in case you were not there, try to go watch that video as well. In part one, we discussed why do we call it as glycolysis. That's because the bond between carbon-carbon that you usually see in organic compounds, that is called as a glycol bond. And lysis basically means to break. Okay. So because you're breaking this bond through different reactions and rearranging the carbon to a different compound, we call it as glycolysis. Now, glycolysis is a very unique chemical reaction, specifically because it can happen for aerobic as well as anaerobic respiration. It does not require the presence of oxygen, and it mainly happens in the cytoplasm of your cells because all the enzymes that you need for glycolysis is present in cytoplasm. Rest of the things will take place in mitochondria in terms of aerobic respiration. Now, glycolysis comprises of 10 steps specifically. Let me give you a little bit of rewind on what it is. The first step would be where glucose starts, which is a 6-carbon molecule. Glucose will get one phosphate through addition of a phosphate in this and turn into glucose 6-phosphate. Then glucose 6-phosphate will be isomerized through another enzyme into fructose 6-phosphate. Fructose 6-phosphate gets one more phosphate and turns into fructose 1,6 bisphosphate. And then this fructose 1,6 bisphosphate will get modified even further and eventually break down into two different molecules. One is called as dihydroxy acetone phosphate or DAP, and glyceraldehyde 3 phosphate, which is called GAP. Now, the interesting part here is that till here, what we discussed actually previous class. Now, GAP is the only molecule that can actually proceed from this point onwards. His twin brother or sister, whatever it is you want to call it, will not be able to proceed, not chemically competent to go through that process. So GAP is the only molecule that continues the glycolytic pathway starting from this point. So till here, it is the step 5. There are 5 more steps through which GAP is going to get modified. So through the activity of another enzyme called triose phosphate isomerase, all the DAP or dihydroxyacetone phosphate will get converted into glyceraldehyde 3 phosphate. Okay, so now you will end up with double the amount of gap because all the twin molecule has turned into this one. So from this, as a result of all this, the DAP molecule will get converted into your gap, and gap will continue from this point forward. Now, where is this? So this is what I was talking about at that point of time. You have these two molecules. They are almost similar looking molecule. The only difference that you're going to see is look at this, look at this, look at this, and look at this. It's pretty similar. It's just there's an exchange of active ions right here. Okay, so this guy, all of it will turn into gap, and then the reaction will proceed. So moving on to the step 6. Now, in case of step 6, all of this DHAP that we had will turn into gap, and it will become double the amount of gap. Now, this gap will go through the 6th step and gain one more phosphate. So here, usually what happens in glycolysis, if you have noticed in the previous slides, go watch the other video, by the way. Whenever there's an addition of phosphate into that molecule, one ATP or adenosine triphosphate usually loses a phosphate and turns into ADP. And that phosphate gets attached to the active compound that we are working with here. Okay, but in here, it's a different equation. So don't get confused in both the cases. This is a unique case. So glyceraldehyde 3-phosphate or 3-GAP will get a free phosphate and NAD plus. Okay, NAD plus. Remember, don't get confused with this plus. Let me just cover it up so you don't get confused. These are the two things that are extra joining in this chemical reaction, or you can say biochemical reaction. And after the active compound has been acted on by the enzyme right here, as you can see, look at the name, glyceraldehyde 3-phosphate dehydrogenase. Dehydrogenase. In case you don't remember, when you learn about different types of enzymes in your biology, you will learn that there are different types of enzymes. There are lytic enzymes. There are hydrogenase, dehydrogenase, oxidase, reductase, which we sometimes also call as redox. So based on different things, just by the name of the enzyme, you can get a pretty good idea what it is going to do. Is it a ligase? Is it a lyase? What does it do? Dehydrogenase, what it does, you can see it clearly in this equation itself. Okay. So here you have the phosphate, here you have the phosphate. Okay. And this guy is right here. This guy is right here. This guy is right here. So you have lost one hydrogen, because of which it is called as dehydrogenase. Okay, it's removing that hydrogen and converting this molecule into 1,3-bisphosphoglycerate. 1,3-bisphosphoglycerate. So what is happening in this whole thing? Not only you're gaining one phosphate because of the free phosphate joining with this molecule, but you're also losing a hydrogen, causing the hydrogen to attach with this guy, and this guy will turn into NaDH plus H. There will also be another plus right here. So keep a note of that. Okay, let me just write it down once again. So NaDH plus H plus. The plus on the H is prefix. Okay, and this plus is just an addition sign. That's all. So you end up with 1,3-bisphosphoglycerate. Now this 1,3-bisphosphoglycerate, this guy right here, he has to go to the next step. 1,3-bisphosphoglycerate here will lose that phosphate that he gained in the previous step. But in here, finally energy production will happen. So glycolysis has been only consuming ATP so far. In the beginning steps also, it has consumed ATP once when it was turning from glucose to glucose 6-phosphate, when it was turning from fructose 6-phosphate to fructose 1,6-bisphosphate, that time also it consumed another ATP. So it has already consumed 2 ATP in the process, but finally here it is actually producing ATP. So hooray! Finally, this loss game is turning into a, finally it is turning into a neutral game. Okay, so 1,3-bisphosphoglycerate with the help of phosphoglycerate kinase will lose that extra phosphate and turn into 3-phosphoglycerate. So which one are you losing here? कौन सा वाला phosphate निकल जा रहा है? That is the one that is at the number 1 location. This guy. Okay, this guy right here. So this phosphate group is gone now. And only phosphate group that is still remaining is this. So you end up having 3-phosphoglycerate. And in the process, the ADP will join with the phosphate that has been released and turn into ATP. So that's one. Okay. Now, very important to note. Do you remember all the DHAP that we had in the beginning turned into gap, isn't it? And each of the gap molecule here eventually is producing one ATP. So technically speaking, this DHAP part also that became gap will also go through the same process and eventually produce one more. So for this guy, we are getting one ATP in a way, and for this guy also we are getting one ATP. So by the end of the reaction, because we started with glucose, right? We started with glucose in the beginning, which is a 6 carbon. This got divided into 3 and 3. So from one glucose molecule, eventually after this 7th step, you will end up having 2 ATP. Now in the beginning, remember 6-phosphate and 1,6-bisphosphate, we used 2 ATP already. So what do you think? Till this point, can we say that 2 ATP gained, 2 ATP consumed? It's nullified, the net is 0 now. So after this point forward, if there is any generation of extra ATP, great for us. That's the profit. If there is no generation of extra ATP, loss ho gaya pura. Okay. So moving forward to your step 8. Now here, where did I go? Oh yes, there's something important that I want to tell you. With this system synthesis, we have cancelled the first two molecules of ATP that we used. The exact same thing that I told you just now. 2 minus 2. 2 consumed, 2 produced. So eventually it has become net 0 ATP but at this point. In step 8, there is a very small change in this molecule. This 3-phosphoglycerate that we have, This 3-phosphoglycerate is going through a very small change in which this phosphate group actually shifts from one to another. Okay, this is a mistake. There will not be any ADP or ATP right here. There is just a small change. That's one of the reason why we call it as a mutage. Okay, mutase. The enzyme itself is called phosphoglycerate mutase because it's basically mutating the molecule and turning it into a different one, almost just like an isomer only. There is no change in the molecule number quantity wise, but qualitatively it is getting changed. The phosphate group that was in this has changed into the second. Okay, so instead of 3-phosphoglycerate, it has turned into 2-phosphoglycerate. Did you understand this part? Very simple. In this point, the only thing that is happening is phosphoglycerate mutase is causing the phosphate group to go from third point to the second point. From here to here. This and this, huge difference. And this OH, the hydrogen will go here if there is an exchange, and they just switch each other's role. So in the ninth step, 2-phosphoglycerate that we have will get converted into phosphoenol pyruvic acid. Why I am dividing this part is because we want pyruvic acid. We don't want the phosphoenol part. So in short form, we also call it as PEP, PIP. Okay. So enolase here, the enzyme, is converting 2-phosphoglycerate into phosphoenol pyruvic acid. Enol, enolase. Okay. Let's see what is the difference between the actual characteristics here. So, okay, let's try to move this side. So the reaction is going from this to this. Okay, so we had the position 2, remember, 3-phosphoglycerate to 2-phosphoglycerate, and after this second position thing, you still have the same connection, and you're just turning it into a phosphoenol pyruvate. This HO that you have is not going to be there anymore. Because of that, very good chances are there that there will be a structural shift in the molecule, which is what you're getting right here, phosphoenol pyruvic acid. Now we need this part. मेरे को तो pyruvic acid चाहिए because pyruvic acid is what is going to get processed in your body as well. So in the next step, which is the 10th step, and this is the conclusive one, phosphoenol pyruvate or TIP will again lose that phospho part. Okay, the phosphate group that has been latched onto that molecule. 2 phosphate group added in the beginning of the reaction, starting of the pathway. At the end also, both the phosphates are exited. So this phospho group will finally leave with ADP. ADP is going to take that phosphate back in and turn into ATP, causing the phosphoenol pyruvic acid to turn into pyruvic acid. Now, the pyruvic acid usually doesn't exist in pyruvic acid because these are weak acids. So it turns into pyruvate. Okay, instead it turns into pyruvate. Now, once again, if you remember, we are standing on 0 right now. 2 ATP consumed in the beginning, first step, first 5 steps, and 2 ATP also given out. So what happens in the next, in this one, again, for every molecule that you're generating, which is one is DAP, one is the gap. If DAP gets converted to gap, 2 gaps will be there. For each gap, you're getting 1 ATP right here. So if the cycle continues twice, again, you will end up having production of 2 ATP. So if I tell you कि from glycolysis कितना कितना एटीपी का फायदा हो रहा है, कुछ मुनाफा हो भी रहा है, कम ऑन 6 स्टैंडर्ड में आपने सीखा है लॉस एंड प्रॉफिट, देन व्हाट आर यू गेटिंग आउट ऑफ दिस? In the first 3 steps itself, 2 ATPs were consumed, so minus. Step 7 and step 10 produced 2 ATPs, so 4 ATPs are produced. So net visible ATP produced here is 2, 4 minus 2. Now, something that you must pay attention to here is that this term written here as visible, net visible ATP. Visible क्यों sir? Invisible ATP क्या होता है? So the way we are putting it visible here is for a reason, because all the byproducts that you produce through your glycolysis, remember NADPH plus H plus. So these molecules are precursors for another reaction, which is called as what? Do you know about it? It's named after a scientist's name, but it actually resembles the name of another crustacean. Krebs cycle, yes, which takes place in your mitochondria. So when it comes to that, these NADPH plus H plus, these molecules will again get recycled in that process, and through that recycling, they will again generate more ATP. It can not only be through Krebs cycle, it can be through the electron transport chain as well, which will again take place in a different part of your mitochondria. We will actually discuss about all of these things in the upcoming classes as well. Now, here, that's the reason why we are putting it as visible ATP gain, because all those secondary molecules that are produced through this process will eventually get converted into something else, and through their conversion, they might generate more energy for ATP production. Okay, so after this glycolysis or glycolic acid reaction, so once the glycolysis is done and you have finally converted all your glucose, six carbon glucose into 3 carbon pyruvic acid or pyruvate. Now the pyruvic acid can finally continue to its next destination. Okay, so in terms of glycolysis, you don't really generate too much energy. You must have seen केवल 2 ATP generate हो रहा है. इतना मेहनत करने के बाद सिर्फ 2 ATP. The actual the actual process or the actual biochemical pathway that generates most of the ATP from the process of respiration in our body is actually the citric acid cycle or Krebs cycle. Okay. By the way, it's crab with K, not like CAOK. Don't get confused with both the terms, even though they sound same, they are not the same thing. So after glycolysis is done, this pyruvate or pyruvic acid can continue in two different mode. As we already discussed, that glycolysis part is common for aerobic as well as anaerobic organism. So does this mean both of them will go through the same process? Of course not. Both of them, if they go through the same process, that is not going to make much sense, right? So for that reason only, in case of an aerobic situation, pyruvate will finally enter into mitochondria where the citric acid cycle or Krebs cycle will continue. Krebs cycle will convert. There is actually going to be a small linkage part also where the pyruvate will be converted into acetyl-CoA, and then acetyl-CoA will be circulated through the cycle, attaching more molecules into it, making it bigger, making it smaller, and through multiple modification, not only it will generate more ATPs, it will also generate more byproduct molecules. Those molecules will eventually go through another process called as ETC or ETS. Depends on, do you call it electron transport system or electron transport chain, in which again multiple different subunits present in the mitochondrial membrane will exchange electrons with each other, causing generation of more amount of ATP. So remember this part. Glycolysis is hardly the investment. Glycolysis is just preparation. You're just preparing the glucose molecule after breaking it into pieces so that the actual precursor for Krebs cycle or electron transport chain can be made. Now, of course, सारे organism तो aerobic है नहीं. What about bacteria such as lactobacillus and all? Yeast, for example, they hardly ever need oxygen. They can still make food out of they can still make energy without requirement of oxygen. So those are anaerobic, of course. They are not going to require any oxygen in any of these steps where they need oxygen. So because of that, no oxygen needed. Chill people, they will directly go into the anaerobic counterpart of your aerobic respiration, which is also sometimes called as homolactic fermentation. Now, it can be homolactic fermentation or it can be some other type of fermentation as well. It depends on what type of fermentation you're going through. And the product of fermentation will usually end up having alcohol, which is a very common fermentation product. That's one of the reason why when you are making bread, the freshly made bread usually gives you that tinge of mild alcohol, because when you're baking the bread, some of the alcohol evaporates because of the heat. But when you cut it open, the inside part, the warm bread part, that alcohol finally finds the exposure to the air and tries to escape. So if you smell it, you get that freshly baked bread smell. So this fermentation part is very important, and fermentation has played one of the most major role in terms of human civilization and preservation of food, starting from making curd to preserving food such as pickles. All of these use the technique of fermentation. There are more different ways you can actually generate energy. For example, aerobic respiration becomes very difficult in your muscles when you are going through a rigorous amount of exercise. Your muscles actually run out of oxygen at that point of time, specifically because your muscles don't have much of hemoglobin. Instead, they have myoglobin, a cousin modified version of hemoglobin, who is, let's just say, utna efficient nahi hai. He's like thoda crippled, so he can't carry as many oxygen as possible, but he's very efficient at carrying it very quickly. So that's one of the reason why your muscles get exhausted very quickly. And when they get exhausted, when your body is not able to provide enough oxygen into the tissue, it also kicks into a different type of anaerobic respiration called lactic acid fermentation. And when you generate a lot of lactic acid in your muscle, it causes your muscles to stun because of the high acidity. And that is sometimes what gives you the muscle cramp also. You must have learned about it in a younger class as well. We will talk about all of these things in more and more detail. But today, for now, that's all. If you enjoyed the class, absolutely go check out the app. Right now, you're learning in on YouTube. So there's a lot of things that I cannot really do directly. I cannot talk to you directly. Even if you have doubts, I might not be able to take care of it. So for that reason only, go check out the live app. The live app is going to allow you to not only take my classes for live, you can also attend many other classes by different teachers as well. Okay. Now, if you do like the class so far, absolutely go join for our crash course. The crash course that we are providing is great for somebody who is trying to prepare for upcoming school exam. अब अभी अभी आप लोगों का स्कूल ओपन हुआ है तो आई एम श्योर यू आर ट्राइंग टू फाइंड अ वे कि इतना सारा सिलेबस कैसे कवर करें. So I have a very good alternative solution for you, and that would be to go ahead, enroll for our crash course. We take this crash course every Monday. Okay, it starts from Monday. It's a 1 week crash course. As you can see, the duration is 1 week. And we start